Hi everyone, welcome to Netgate Chemistry. So today also we are going to solve some of the previous year questions of CSIR net from the topic Polymer Chemistry. So this question which we are going to discuss first is asked in December 2018 exam. It says that the osmotic pressure small p of a polymer sample at different concentration pi was measured at T Kelvin. A plot of pi by c versus concentration gave a straight line with slope m and intercept c dash. The number average molecular weight of the polymer is. So basically we have to find out mn, the value of mn, right? So we have already studied this equation in the polymer chemistry videos, that pi by c equals to RT upon m into 1 plus BC by m plus so on. Remaining terms we neglect here. So from here what we get, pi by c is equals to RT by m. If we open the bracket, then we get RTBC by m square. This is what we get. So now from here what we can do is, we can equate this equation with y is equals to mx plus c, which is the equation for straight line. If we equate this with the equation of straight line, what we get for this, if this is the straight line and we compare this with this equation, then on y-axis we'll be having pi by c. On x-axis we will be having the concentration term, right? This intercept will represent c dash and slope will be small m, right? Suppose the intercept is c dash and this slope is small m for this equation. So this c dash is representing this c dash intercept, or here you can say this is c dash. So c dash is RT upon m here. So on equating, what we get, value of c dash is equals to RT by m. And here they are talking about osmotic pressure. That means they are talking about the osmometry. In case of osmometry, the mean molecular mass which we calculate is the number average molecular mass that we know. So here we are talking about mn, nothing but mn. So the value of mn from here, if we calculate, then what we get is mn is equals to RT by c dash. If we take this mn here to the left hand side and c dash to the denominator to the right hand side, then we get mn is equals to RT by c dash, which is the option A. So option A is the correct option. So now we'll move on to the next question. So the next question says that a sample experiment revealed that PVC formed in the medium has Mn equals to 13 and Mw equals to 16, where Mn stands for number average molar mass and Mw stands for weight average molar mass. So we have to find out the variance. So simply we have to apply the formula for variance, which is represented by sigma square, and that is equals to Mn into Mw minus Mn. We just have to put the values. We have been given the values of Mn and Mw. Just substitute the values. 13 into 16 minus 13. That will be 13 into 3. That is 39. So 39 is the correct option. Very easy to do question. So now we'll move on to the next question. So this is the next question. By the way, the previous question was asked in the December 2014 exam, and this question was asked in December 2017 exam. It says that a polymer has the following molar mass distribution. So basically N1, N2, M1 and M2 are given, and we have to find out the value of number average molar mass. So we just have to apply the formula for Mn, which is equals to sigma Ni Mi upon sigma Ni. For this question, this formula will reduce to N1 M1 plus N2 M2 upon N1 plus N2. We just have to put the values. This is N1, this is N2, this is M1, and this is M2. We just have to substitute the values. So what we'll get after substitution is 50 multiplied by 5000 plus 75 multiplied by 6000 divided by 50 plus 75. So after solve, what you'll get? After solving, you will get 5600 gram per mole as the answer. So option B is the correct option. So with this, we'll move on to the next question, next and the last question of this video. So this is the next question. It was being asked in December 2015 exam. So the question says that the average end-to-end distance of a random coil polymer having 10 raised to power 6 monomers, and we have to tell in terms of segment length. So we just have to apply the formula for end-to-end distance when we have to find the monomers, the end-to-end distance in terms of segment length. So the average end-to-end distance is equals to root n, where n represents number of monomeric units. So we have been given the value of number of monomeric units, that is 10 raised to power 6. We just have to substitute this value over here. So what we'll get is root under 10 raised to power 6, or you can write it as 10 raised to power 6 whole to the power 1 by 2. 6 into 1 by 2, that is 10 raised to the power 3. So this will be the answer. So the correct option is option D. So this is the correct option. So I think so far that's it for this video. Thank you so much for watching.